Are you searching for the perfect charging solution for your electric vehicle? Yeah, then you are just at the right place. I welcome you, ladies and gentlemen, to our today's Fronius webinar about our Fronius Wattpilot charging solution. If you have any questions during the webinar, please feel free to use our chat functionality. We are going to answer your questions, of course, right away. My name is Michael Raunig, and together with my colleague Christoph Schillinger, we are going to help this webinar today for you. So, charging on my terms. Yeah, with this saying, we want to start in our today's webinar, and today I'm going to show you the best and newest features of the Fronius Wattpilot. I'm going to show you on what the Wattpilot is capable of doing and what can you actually charge with the Wattpilot, how can you use the charging modes, and what functions and features are available for the device. So first of all, we are going to start with a little overview in e-mobility and photovoltaics, and therefore I'm going to show you why e-mobility and photovoltaics is the perfect match for your system and why these two components, these two sectors are so good integrated with each other. Second on, I want to show you the 3 different charging modes that are available with the Fronius Wattpilot, and therefore we are going to show you how to integrate the Fronius Wattpilot into Soloved in our monitoring platform, how you can use the data coming from your e-mobility to use it in Fronius Soloved. Last but not least, I'm going to show you today the load balancing functionality and of course the integration of Open Chargepoint Protocol 1.6, as well as some application cases that you can use with the Fronius Wattpilot. So let's start right away with the first topic, e-mobility and PV. And as you might know, these two sectors are the perfect match for each other. So first of all, of course, you want to use your own PV energy coming down from the roof to charge your electric vehicle. And on the other hand side, your mobility gets greener and greener when you charge the electric vehicle with your own PV surplus energy. But however, of course, there is a problem when you do that without intelligent control. So let's have a look on a standard load profile in a household. As you can see here, the blue area on the left side, this is the PV curve that occurs during the day. So if you see here, there is a lunch peak, so peak production, and as well the red area before that, this is the household loads that are being operated in the household. Yeah, and when the house owner now comes home at around 4 or 5 p.m. and he plugs his electric car in and charges at maximum power, then there is one kind of a problem, because then you are drawing a very high power even from the public grid. And first of all, we want to support the public grid. So we want to avoid that there are peak loads being delivered from the public grid. And of course, as you can see here, when we are charging with maximum power without in regards to your PV system, of course, you are drawing a very high peak load from the public grid. You're using energy from the public grid. And of course, this is on one side bad for the public grid because you are drawing a very high peak load. And on the other hand side, for your economics, for cheap charging process, of course, you are not using most out of your PV system. As you can see here, only low autarky grades are being reached here, and you're not using the full potential of your PV system. So therefore, at Fronius, we can deliver you 2 different options to charge your electric vehicle intelligently. First of all, you can do this with the intelligent control of the Fronius inverter digital IOs. So with this digital in and outputs, you have the possibility to control the charging process. And this can be done stepwise, so you can lower down the peak power of your PV system, of your charging solution, and therefore use the PV energy that comes down from your PV roof to use it in your electric vehicle. So in this case, we lower down the peak power, we are lowering down the charging power of the electric vehicle and use it over a bigger time frame. Furthermore, of course, you can also implement a night charge. So when there is not enough PV energy to charge up your electric vehicle during the day, for example, then you can still charge it during night times. However, this is only possible with one fixed current, so with one fixed charging power. And therefore, we have the second solution, and this is the dynamic control with the Fronius Wattpilot. And with the Wattpilot, it is now possible to really dynamically charge your electric vehicle depending on what comes down from your PV system. So whenever the electric vehicle is being charged, you will get the perfect match from power from the PV system to the load of your electric vehicle. So with that, as you can see here in the right schematic, you can see that the PV power is perfectly used for charging your electric vehicle, and the power is always dynamically controlled by the Wattpilot to just use that amount that is coming down from the PV system at the moment. So therefore, you can see with the dynamic control, you can really follow the load of your PV system. You can follow the energy that is being produced. And therefore, on the one hand side, we can support the public grid because we are avoiding peak loads from the public grid. On the other hand side, to charge at the possible cheapest rate, you can always use the cheap energy that comes down from a PV system to charge up your electric vehicle and to drive at the end of the day at very low cost. So let's have a look on the first solution with the load management with the Fronius inverter integrated IOs. So you have the possibility to use these digital IOs. As you can see here on the left-hand side, we have these little digital IOs. These are just 12-volt DC signals, and you can use them with a standard 12-volt relay. And the relay will then switch on and off your charging solution. So in this case, as you can see here, we have a standard outlet plug, and you can connect your electric vehicle to it. And the relay will then switch on and off the load path to implement the charging process whenever there is the signal coming from the Fronius inverter that there is PV surplus energy available. Yeah, how does that look like now in the daily curve? As you can see here, we have an example of a PV system. The gray area is the produced energy from the system, and then here the orange area is actually the load that is being taken from the electric vehicle. However, as you can see, we are only using it as a step charge, so only one fixed power, and therefore, of course, not all of the PV system can be used. As you can see, the right area here is not being used, and therefore you are losing on money, of course. So this is one solution, and on the other hand, we have the dynamically controlled with the Wattpilot, and the Wattpilot can now directly communicate with the Fronius inverter. Therefore, really important in this system, as you can see here in the schematic, we have a Fronius smart meter at the feeding point. And of course, the Fronius smart meter is always important to implement with these systems, because with the Fronius smart meter, you have the possibility to detect and visualize the energy flows going out of the system and coming in from the public grid. And therefore, with the data from the Fronius smart meter, the inverter knows when there is PV surplus energy and when there is being energy taken from the public grid. Yeah, and with this data, the Fronius Wattpilot can now communicate over our solar API standard. This is being done over Wi-Fi, over wireless LAN, and therefore the Wattpilot has always a connection to the inverter, and then inverter can then tell the Wattpilot when there is PV surplus energy available, and the Wattpilot will take this information and charge the electric vehicle at the right pace. Yeah, this system is then being possible, of course, with the Fronius Snap Inverter series, as you can see here, as well as with the Fronius Gen 24 Plus series, and as well, of course, also with the Fronius Tauro. So no matter which Fronius inverter you have, the Wattpilot is compatible with it, and you can instantly use it for charging with PV surplus energy. Yeah, how does that look now in the daily curve? So as you can see here, the energy and the load is being taken from the inverter. So the Wattpilot knows instantly what power is available, and it will regulate dynamically after this PV surplus curve and will take all the power that is available from your PV system. With that, it's then being possible to charge at the most economical rate, because all the power coming down from your PV system is then being dynamically charged into the electric vehicle. Yeah, let's take a closer look now on the Fronius Wattpilot on the device itself. So first of all, there are two basic variants of the Fronius Wattpilot. First variant is the Wattpilot Home, and second is the Wattpilot Go. So basically, you can decide between a stationary solution and a mobile solution. As you can see here with the Wattpilot Home, the Wattpilot device comes with a 2-meter fixed installation cord, and you can install that to a wall outlet or, of course, to a socket. Yeah, and on the other hand side, the Wattpilot Go is then our mobile solution. It comes always standard with an electric plug. And the Wattpilot is thought as a mobile device so that you can take it with you in your electric vehicle and charge wherever you want. So whenever you find an electric socket, you can connect the Wattpilot to it no matter where you are and charge your electric vehicle. So therefore, this mobile solution is being thought as you can take it with you in your electric vehicle, but of course you can also use it at your home. So whenever you have an electric outlet in your garage, for example, you can directly connect the Wattpilot to it and use it as your charging solution. Yeah, there are then two possible variants for the power. So there is always a Wattpilot Home 11 kilowatt device and a Wattpilot Home 22 kilowatt device. Same goes for the Go devices. So there we have also 11 kilowatt device and a 22 kilowatt device. So that means that there is a variant that is applicable of a maximum charging power of up to 11 kilowatts or a maximum charging power of up to 22 kilowatts. So the regulation then goes from, in this case, 6 to 16 amps. So this is the maximum current range that you can use. Why is it 6 amps? This is very easily explained. The electric vehicles, they need a minimum charging current that they start the charging process. And this is at 6 amps for all the electric cars out there. So they are starting the charging process at 6 amps. So therefore, the Wattpilot is regulating the power, so to say, between 6 and 16 amps for the 11 kilowatt device, and between 6 and 32 amps for the 22 kilowatt device. Yeah, what comes with the standard delivery? First of all, there comes, of course, the device, and then you will get the mounting plate. So with that mounting plate, you have the possibility to install the Wattpilot to your wall. For example, if you have a garage or a carport, you can instantly install the Wattpilot mounting plate to the wall. And the benefit of this mounting plate is that you can just take the Wattpilot from the wall and take it with you in your electric vehicle, for example. So therefore, the mobile solution is supported in this case, that you can just unplug the Wattpilot from the wall and take it with you. Furthermore, there comes the RFID reset card. So this little card that you can see here is being delivered with the standard content. And with this RFID reset card, of course, you can reset the Wattpilot to the factory settings. And also for the initial commissioning, there are dates written on the card how to initially commission the Wattpilot. Furthermore, you will get a RFID chip, and you can see this RFID chip as a key for the Wattpilot, so to say. So you can learn up to 10 RFID chips to the Wattpilot device to avoid that other people are using the device. So with that, you can lock the Wattpilot and make sure that only you as the customer can access the Wattpilot and can start the charging process. Yeah, then there is, of course, also a theft protection. So whenever you install the Wattpilot at the public or semi-public place, you can just use this theft protection. This is being installed over the connection cord, and you can just secure it with a padlock, for example, and then make sure that nobody can withdraw the Wattpilot from the wall. Yeah, then we have, of course, optional accessories for the Wattpilot. And since we have a mobile device, of course, these adapter cables are very important for the mobile use. So whenever you are on the go, you want to adapt the Wattpilot to whatever socket you find. So therefore, we have 3 different adapter cables available. First one, of course, is the adapter cable for the Schuko socket. So whenever you want to charge on a Schuko socket, you can do that. And there is just an adapter cable where you can adapt the plug of the Wattpilot, in this case, the CEE red plug, to the Schuko socket. Furthermore, there is an adapter to the CEE blue socket, so to the Kara socket. And then, of course, you have one CEE adapter to 16 amps or in regards to 32 amps, depending on what device you are using. So please make sure when ordering the adapter cable that you're ordering the correct one for your 11 kilowatt device or respectively to the 22 kilowatt device. Yeah, furthermore, of course, you can order multiple mounting plates. So whenever you want to install the Wattpilot at different locations, then you can order an extra mounting plate as well as a cable suspension. So whenever you want to suspend your cable to the wall, you can just easily do it with the cable suspension. Furthermore, you can order the RFID chips. There are a pack of 10 integrated, and therefore you can do the authentication on the Wattpilot device with these 10 chips, as well as you can also order, of course, a Type 2 cable to charge your electric vehicle. Yeah, what about now the installation of the Wattpilot? So what do you need to keep in mind when installing the Wattpilot? First of all, in the installation, of course, you need an FI Type A with 30 milliamps, so a circuit breaker to make sure that there are no error currents on the line. Furthermore, you need a standard circuit breaker, and then you need, of course, a connection line to the device. Therefore, you need a minimum of 4 square millimeter. However, we recommend to use a bigger diameter like 6 square millimeter, 8 square millimeter, depending on the length of the line and depending on the power that you want to go over with. Yeah, and then at the garage or at the carport, so at the place of charging, you just need to install a plug, an outlet in this case. And of course, most sense makes to install instantly a CE three-phase plug with 16 or 32 amps, depending on the Wattpilot. Or of course, you can also install a single phase CE one phase. For example, if you have a single phase household, you can also install a single phase CE plug here. On the other hand side, this goes for the Go device. For the home device, you can also install a connection socket for the Wattpilot Home and then instantly install the Wattpilot Home to this connection socket. Yeah, furthermore, for the data communication, we recommend you to use a power line adapter. So most of the time, when you install the Wattpilot in the garage or in the carport, the Wi-Fi signal of your home will not be sufficient to reach the Wattpilot. If it does, of course, this can be used. If not, please use a power line adapter. We have made very good experiences with it. So whenever you go with the electricity to the carport or to the garage, then you can instantly also install a power line adapter and taking the internet signal over the power line to forward the signal to the Wattpilot. And this makes sure that you have a good connection to the Wattpilot, that the connection is never being lost over the Wi-Fi signal, and that you will always get good data from the inverter and of course to the internet to Fronius Soloved. Yeah, as you can see here, in this installation process, you don't need an FI type B, and this is very important because this can lead to additional costs. And in this case, the Wattpilot has that already integrated because we are using an RCMU in the Wattpilot, and therefore we have no need of installing a type B in this case, and this saves you on cost for the installation proposal. So please always keep that in mind when installing an e-mobility solution, that it integrates the type B characteristic or of course the RCMU in the device. Yeah, what are now the limits for the charging capacity actually? And more or less there are 4 limits that you need to keep in mind when installing a solution at the customer place or when installing your own e-mobility solution. First of all, very important, of course, is the supply line or the house connection. So depending on your house connection at the site or on the supply line that leads to the socket where you connect the Wattpilot, this is determining on how much power you can draw from that line. Of course, very important. Second factor is then, of course, the wall box or the mobile charging cable that you're using. So depending if you're using an 11 kilowatt or a 22 kilowatt device, this depends on how much power you can draw from the public grid. Yeah, and then third factor is of course then the used type 2 cable, and please watch that very closely because there are different type 2 cables on the market and there is a coding on each and every cable to not override the maximum current of the cable. So for example, there are cables coded to 16 amps maximum, or there are other cables coded to 32 amps maximum charging power. And depending on which type 2 cable you're using, this determines the limiting factor for charging capacity. Yeah, and then last but not least, so one of the most important facts about charging power is the onboard charger of the electric vehicle. So depending on which electric vehicle you're using, there are different onboard chargers out there in the market. So let's name it. There are some electric vehicles on the market that can only charge on a single phase, for example. And then there are the most of the electric vehicles out there that can charge on 3 phases. However, there is a maximum current that the onboard charger of the electric vehicle can take. So therefore, the electric vehicle at the end of the day determines the power of the actual charging process. So for example, it makes no sense or it doesn't help you if you install a supply line and the house connection with 32 amps, then use a Wattpilot with 32 amps, so the 22 kilowatt variant. Also, you have a type 2 cable that you can use 32 amps at the 3 phase, and then you're using an electric vehicle that you can only charge on 1 phase with a maximum of 16 amps. So do you get it? In this case, the maximum charging current will be at 4.6 kilowatts instead of you installing a 22 kilowatt solution. So please take care very closely when installing. Please take care when communicating to the customer, of course, that you don't have false expectations, because the electric vehicle, the type 2 cable, the wall box, the charging solution, and the supply line, they determine the maximum charging power that you can really reach in practice. So therefore, the weakest chain in this part, so to say, determines the power that you can actually be achieved in the household. So therefore, please watch that very closely when installing your electric mobility solution. Yeah, next chapter is then about charging with the Fronius Wattpilot. And here we are going to have a look on how you can use the charging modes, how you can charge with the Wattpilot at once. First of all, of course, Fronius Wattpilot is an easy charging solution. So with the Wattpilot, you have the possibility to instantly charge your electric vehicle like you would with any other solution out there on the market. Therefore, we have very important here a little button on the front side of the device. And with this button, you can instantly alternate the charging current that you want to use for the charging session. So with the first charging mode, it is called the standard mode. You can just plug and play. You can just plug in your electric vehicle and charge at the fixed current. So for example, with the button, you are selecting 16 amps, and then you can charge with 16 amps standard for the standard charging mode. Of course, you can alternate these charging currents. So for example, depending on which outlet, on which electric outlet you are, you have the possibility to alternate the charging current, for example, to limit the charging current when you know the socket doesn't supply, I don't know, for example, 20 amps, then you can limit the charging current down to 13 amps, for example. Yeah, then this goes very intuitive. You have here these little blue LEDs around the Type 2 socket, and each and every LED spot stands for 1 amperage. So that means, for example, when we have 6 LED spots on, that means that you will charge with 6 amps of power. So therefore, you can easily visualize in front of the device what's the charging power that you want to achieve. Of course, you can also alternate this with our Fronius Solar Wattpilot app. So if you don't want to do it over the device directly, you can just enter the app and also make all the settings that you can do in front of the device over the Solar Wattpilot app instantly. So then that brings us to our first PV optimized charging mode. And this PV optimized charging mode is called the Eco mode. With the Eco mode, the Wattpilot will now make sure that only PV surplus energy is being used for the charging process. So in this case, that means whenever there is PV surplus energy coming down from the roof, the Wattpilot will take this surplus energy and charge it into the electric vehicle. With Eco mode, the dynamic control is fully optimized. So in this case, as you can see here on the right-hand side, we have here a production of the PV system, and the Wattpilot will always take the energy, here colored in violet, that is available from the PV system to power your electric vehicle. Also, a very good thing is in Eco mode that you are not drawing energy from the public grid and even not taking power from the stationary PV battery if you have one. So in Eco mode, you can really make sure that you are only charging at a very low cost, only with the PV surplus energy of the PV system. However, in Eco mode, that means that you are only charging with PV surplus energy. So this means, for example, when you have a winter day and there is snow on the modules and you don't have PV energy at all, that means that with Eco mode, there is the possibility that the electric vehicle isn't charged at all. So this means that there are no charging takes place. So for example, you will take Eco mode when it is a weekend, when it is Saturday, and you know on Sunday you don't need to leave the house, but you want to make sure whenever there is PV surplus energy coming down from the roof, you want to make sure that your electric vehicle uses the power. Therefore, Eco mode will make sure that it uses the power. However, when there is no PV surplus energy, the electric vehicle isn't being charged at all. So therefore, to overcome this problem of Eco mode, so to say, we have a second mode. It is called the next trip mode. And with next trip mode will basically do the same as Eco mode. So it will always watch that it is only using PV surplus energy. But plus to that, next trip mode can also be configured to a minimum range, to a minimum mileage of the electric vehicle, and you can determine on how much energy is being charged in the electric vehicle at no cost, so no matter if there is PV surplus energy or not. So let's take this to another example. For example, it is Monday and you know on Tuesday you have to go to work again, and therefore you want to make sure that a minimum of 16 kilometers of mileage, 16 kilometers of range are being charged into your electric vehicle. So this would mean that you can just configure this over the app. You just give it a 60 kilometers minimum range until, for example, 6 a.m. in the morning, and therefore the Wattpilot in next trip mode will make sure that these 60 kilometers of range are being charged until 6 a.m. in the morning. So with that, you can make sure, for example, when it is Monday, there is a winter day, there is no PV surplus energy, there is snow on the modules, for example, then the next trip mode will make sure that the 60 kilometers are being charged into the electric vehicle. If there is PV surplus energy available during the day, the next trip mode will use it. If not, the Wattpilot will also take it from the public grid, or it can also take it from the PV stationary battery that you're using in your household. So therefore, as you can see, you can use the Wattpilot how you want and how it suits you best for your mobility needs. There is another big feature coming with the Wattpilot that is very vital for PV surplus charging. And this is the single and three-phase switchover capability. And whenever you have made experiences with PV surplus charging, of course, there is somewhat a problem with only charging on a single phase or only charging on a three-phase system. So whenever you are making thoughts about the control of the Wattpilot and control of the charging solution, you will instantly get to the point that when you can control the charging process in single amp steps, one phase, also on a single phase, you will have 230 watt steps, and on charging on three phases, you will have 690 watt steps. And this would mean that you can regulate the charging process dynamically, but still, if you're only charging on a single phase, you have the problem that you are somewhat limited on the power. And when you only charge on a three-phase system, that you need a very high power to start the charging current. So when we have a look on the column down here, we see that when we charge with 6 amps, so this is the minimum charging current for the electric vehicle to use, for a single phase system, we start at £1.38 kilowatts, whereas for the three-phase system, we start at £4.14 kilowatts. So this would mean when you have a rather small PV system, let's name it, you have a 5 kilowatt peak system on the roof, this would mean that you barely get down £4.14 kilowatt of PV surplus energy ever. So this would mean when only charging on three-phase system, you will never get to start the charging process because you don't get down £4.14 kilowatt. On the other hand side, when you have a very large PV system, and of course you have a 20 kilowatt peak system, you want to use the power that is coming down from the PV system, of course. And when you now only charge on a single phase, for example, you are somewhat limited in the power because the charging process starts with 1.3 kilowatts. And for the most households, there are a maximum of 16 or 20 amps available. So therefore, you are limited to 3.6 kilowatt or maximum 4.6 kilowatts. And when you want to use your 20 kilowatt peak system, of course, you are limited on the power and the system can't regulate any higher. And therefore, the functionality of the Wattpilot is so important. It is called the single and three-phase switchover. So this means that the Wattpilot automatically switches between single phase and three-phase charging. So this means, for example, in the morning time, the Wattpilot can start with a single phase with 6 amps, so 1.3 kilowatts, and then regulate the power up to a maximum, for example, of 20 amps or 16 amps. And then when it reaches that power, when the PV system is delivering more power, it can automatically switch over to the three-phase charging and charge on with 4.14 kilowatt and at the maximum of 22 kilowatts. So this means with the automatic switch over of the phases, you can use the full potential of your PV system, the full power, down from 1.3 kilowatts up to 22 kilowatts. So this is very vital for a charging solution. And please note, whenever installing a PV surplus installation, please note that your device can do this automatic switchover from single and three phase, since it is so important for your PV system to use the full power of your PV system. The Wattpilot can do it. He can automatically switch over the phases from single and three phase, and therefore make sure that you can use the most out of your PV system. Yeah, in this graphic on the right-hand side, you can see how the system works. So in the lunchtime, for example, there is more power available. Wattpilot charges on three phases, then regulates down the power until it hits the single phase mark. and then the Wattpilot will automatically switch over to single phase to use the rest of the day when there is lower PV irradiation available, to use the power still to charge up your electric vehicle until a minimum value of 1.3 kilowatts. So therefore you can see you can really use the full potential of the PV system, use the full power, and you're not losing on power and not losing energy in this case. Yeah, first feature that I want to show you here now is the integration in Soloved. And whenever you're using Fronius Soloved, of course, you also want to achieve the data from the Wattpilot. And in this case, with the integration in Soloved, you can read out all the data that you would have in the mobile app, in the Solar Wattpilot app. You can also read out this data in Fronius Soloved. So therefore, you can manually add the Wattpilot in Fronius Soloved. You can read out the energy balance of the device. You will have the bubble chart. So in the bubble chart, you can instantly see the power that is being drawn from the Wattpilot at the moment. In the history chart, you will have detailed values for the visualization needs, and of course, also very important, the report functionality. Therefore, you can generate personalized report for the Wattpilot data. First of all, of course, for visualization purposes. So whenever you want to know how much energy does my electric vehicle take per month, per week, per year, for example. And on the other hand side, for troubleshooting, this is very important for you as an installer. For example, when you want to do troubleshooting at the customer side, with the history chart, you can also see the historic data and value to do a troubleshooting at the customer side. Yeah, so for the energy balance, you can watch it day, month, and yearly, of course, and therefore you can easily see the power that is being drawn from the Wattpilot. So in this case, we see here the violet area. This is the energy that is being drawn from the Wattpilot. As you can see here, the customer plugs in his electric vehicle at 1 p.m. in the afternoon, and then charges with the dynamic regulation until the electric vehicle is being fully charged, and then the Wattpilot stops the charging process. On the other hand side, for monitoring and visualization, you can see here the values that are being delivered from the Wattpilot, and therefore visualization is very easily when the customer wants to know how much energy do I use for my electric vehicle, you can use it instantly for reporting functionalities. Yeah, furthermore, in the analysis chart, you can see very detailed information like voltage per phase, current per phase of the Wattpilot. You can see the power factor, the device performance, as well as the Wi-Fi signal strength. So with this, for troubleshooting, this is very interesting. And also for monitoring purposes, you can use that instantly to watch what your Wattpilot or your electric vehicle, for example, is doing. Yeah, for the integration in Soloved, please note, however, first off, before you bring in the Wattpilot into Soloved, all the devices, inverter and Wattpilot, must be updated and online. This is very important. Then also one Wattpilot can be coupled with one inverter at the same Soloved system. And of course, please also note that the data of the Wattpilot is not being stored when there is no internet connection. So let's assume you are taking your Wattpilot with you on the go. You have a mobile situation and you don't have internet connection, then the data is not being stored without internet connection. Yeah, then of course, please also make sure to update your Wattpilot to the firmware minimum 36 and the Gen 24 and Tower firmware at a minimum of 1.12. Yeah, and then when you update these two systems, you can instantly put it into Soloved. You can just add the Wattpilot under components. So when you enter your Soloved system, you can go to settings, components, and then make sure that you bring it online in your Soloved system. So therefore you can instantly couple your Wattpilot with your Soloved system. So next point that I want to show you is a very important functionality, of course, not only when you're using multiple Wattpilots, but only when you're using one Wattpilot and have somewhat of a limited household connection. And this feature is called the load balancing in Fronius Wattpilot. With the load balancing functionality, you can now make sure that you don't override a maximum available current at the household connection and that there are no overloads of your household connection. So this is very important. Let's name it. You have a limited household connection with at the maximum 20 amps, and you want to make sure that your Wattpilot is being charged at the maximum current without overloading, without blowing the fuses of the household. So in this case, this means with dynamic load balancing, you have the possibility to interconnect up to 3 Wattpilot devices at the same time. and to use the maximum available current from the household connection. So as you can see here in the right hand side, for example, we have a maximum available current in the household connection, for example, with 20 amps. Then we can divide this maximum current to 2 Wattpilots, for example. And the nice thing is now that you can also use the current coming down from the PV generator to charge even faster than what your household connection is capable of doing. So for example, you have a maximum available current in the household of 20 amps. However, your PV generator is delivering 10 amps. Then you can use this 10 amps to charge faster than what your actually household connection is capable of doing. So in this case, we have 13 amps available from the PV system 10 and from the household connection 20, and then we can divide 15 amps to each and every Wattpilot and charge faster with the help of the PV system. So this is a very important functionality, of course, because then with the help of the PV system, you can actually charge your electric vehicle faster and charge at a higher power. However, please make sure, of course, for the load balancing functionality, again, you need to have the Fronius smart meter at the feeding point. This is very important since we need to measure, of course, the maximum load, the maximum power that goes over the feeding point. And of course, you can also have a solution for single or two-phase cars. So whenever you're charging on a single phase, or some cars also charge on 2 phases, then you also have a solution for that, and you can limit the maximum charging current of that. Yeah, however, please note the PV optimization is still available on only one device. So for example, when you are operating 3 Wattpilots, 1 Wattpilot can charge with the PV optimization, and the other 2 Wattpilots, they are being charged in standard mode, so they are being charged with a fixed charging current. However, you can make sure, of course, to use the PV optimization one after each other. But for example, if you want to charge all 3 electric vehicles in a row, you can do it with 1 PV optimized device and 2 standard mode devices. Yeah, please note the app version needs to be at the minimum of £1.75 for that, and the firmware version of the Wattpilot needs to be at £39.6. Yeah, so how does the dynamic load balancing work now? First of all, we have here a connection point. In our example, we have a 32 amp connection point. We have here the public grid, the utility meter, and right after that, in the feeding point, we have the Fronius smart meter. We have then 2 Wattpilots available. We have a Fronius inverter, and the household loads, they are being taken 16 amps at the moment. And here we have 1 electric vehicle plugged into the Wattpilot, and we are drawing 16 amps. So this means the maximum of 32 amps from the household connection. So what happens when we are now plugging a second electric vehicle? Dynamic load balancing will make sure that your fuses are not blown, that the household connection is not overloaded, and therefore just divides the current of the 2 Wattpilots to each and every 8 amps to make sure that there is no overload at the household connection. So then there are coming down 8 amps from the Fronius inverter, so the PV system is delivering energy. Therefore, we can drive up with the power on the Wattpilots, and therefore we can drive up from 8 to 12 amps and charge the electric vehicles faster. And as you can see here now, we are charging with more current than what the household connection actually can be doing. Yeah, then of course, also when the household loads get higher, for example, when the household loads are being switched on and it uses 20 amps, then of course the Wattpilots will regulate down with dynamic load balancing to avoid overload on the household connection. So the power is dynamically regulated to avoid overload in the household connection. So this is about power regulation. And on the second thing, we can do a prioritization of the loads, of course. And therefore, this is really important when you have, for example, 3 Wattpilots in a row, and you want to give it a prioritization of the loads to make sure that your most important electric vehicle is being charged first, and then the second and third car is being charged later. So therefore, we have 3 modes of priority. So we have the 3 modes, low, medium, and high. And with these priorities, you can easily give off priority. So for example, priority number 1 has the first Wattpilot. There is a car connected, and the connection point gives off 32 amps. And therefore, all the 32 amps are being delivered to the first car because it needs the power first. Second and third car, they will be regulated down to 0 amps in this case, and they will get the charge later on. So when the first car is then being charged fully and leaves the charging station, then of course the current can be divided. So in this case, both Wattpilots have the priority low. They they use the same priority, and therefore they are divided with 16 amps, and each and every car gets the same amount of power. Yeah, and then even when the last car leaves the electric vehicle, the charging station, then of course also the priority low can get the highest possible charging current to charge at a fast pace. So with this, it's possible to give it a priority, and of course you can also divide the priority. So when you give, for example, 2 times priority low, then the charging current will be divided on these 2 charging stations to make sure that every electric vehicle gets the charge. Furthermore, please note also the charging mode has a influence on the charging modes. So whenever, for example, you're using one electric vehicle in the eco mode, this means that this electric vehicle will get the charge later on. This is since, of course, the knowledge that in eco mode you are charging somewhat optionally because you want to use only the PV surplus energy. So therefore, standard mode, for example, goes always first before next trip mode and eco mode. So this is also one way of prioritization of the loads. Yeah, and with this prioritization, you have really the possibility to control your system and to control multiple Wattpilots however you want to. Yeah, the last but not least, very important functionality today is the Open Chargepoint Protocol 1.6. And with OCPP 1.6, let's go through what is OCPP and how can you use it. First of all, Open Chargepoint Protocol is a standard software interface that can be used for communication between the charging station and a so-called back-end solution. So whenever you want to forward the charging process to a backend, for example, for regulation purposes, for controlling methods, or even for billing, then you want to use OCPP as a standard protocol. So let's take this to an example. For example, you have an end customer coming with a so-called RFID card to the Chargepoint operator, so therefore a charging station installed somewhere. Then you can authenticate with the RFID card directly on the device. And then this charging process, so for example, time or energy, is being built over the internet, over the so-called backend OCPP. And with this protocol, the data can be forwarded to a so-called e-mobility service provider, the eMSP. And e-mobility service provider can now build the charging process to the vehicle user, to the vehicle driver. And of course, he has a contract business to customer in this case, and build the charging process to the vehicle driver. Of course, then the e-mobility service provider can also pay the Chargepoint operator for the charging process, and therefore it is very easy for the Chargepoint operator to implement the charging billing, because, for example, if you take into account a restaurant or a hotel, they don't want to do the billing for themselves, but they want to give it away to an e-mobility service provider that does the billing for them. So therefore, the OCPP is so important for connecting Chargepoint operator with the e-mobility service provider to build the charging process or to forward the data. Yeah, this can be done with different companies. One example is here has to be, for example, that can do the billing for the end customer. And on the other hand side, and this is really important for us as Fronius, we also use the Open Chargepoint protocol for our Fronius email application. Fronius email is now a bigger load balancing functionality. With Fronius email, you can balance the loads within a commercial use. So whenever, for example, you have a big company and you have a car park of, let's say, 20 charging points, you want to make sure that you are not overrating the household connection or the connection of the fuses, that you don't get an overload of the connection point. And therefore, Fronius email can do exactly that. With Fronius email, this is a software solution and it can regulate down the charging points that you don't override the connection point and you don't overload the connection point. And therefore, we are also using the Open Chargepoint protocol, OCPP 1.6. And with that in mind, we can control the charge points over Fronius email. Yeah, there are of course more features of the Fronius Wattpilot. First of all, we have a cable lock functionality. Of course, this makes sure that you are not able of cable theft, so that nobody can take the cable from the Wattpilot. So the cable is locked in the device. Of course, you have also optional the padlock that you can theft protect the Wattpilot with it. And then, of course, very important, we have here the residual current device integrated in the Wattpilot, so you don't need to have a type BFE in this case to installation of the Wattpilot. Yeah, then of course we have a phase and voltage examination. So therefore the Wattpilot also watches the phases and voltages. Monitoring of temperatures is really important, especially when you're charging on a Schuko outlet, for example. Then the Wattpilot will take the work for you and do the monitoring of temperatures. Yeah, and last but not least, of course, you can also do a user log with the RFID tags to make sure that no other people can charge with this solution. Yeah, last but not least, for the end of the webinar today, I want to show you some application cases that can be covered with the Fronius Wattpilot. First of all, and this is a topic that comes up very often, Wattpilot can also be operated with external sources. So let's name it. Maybe you have an external inverter, external PV inverter, third-party inverter, or maybe you have a small hydropower plant or a wind turbine. Of course, then you can also use the Wattpilot functionality with this external device. So let's see it here on the schematic. We have a third-party inverter with a PV generator, maybe an existing system. Then all you need to do is to implement the Fronius smart meter at the feeding point, of course the Fronius Wattpilot for charging, and then last but not least the so-called Fronius data manager box 2.0. And with this data manager box you can have a Fronius data source, so to say, and it overtakes the functionality of the inverter. So therefore with the data manager box you can communicate over Solar API with the Wattpilot, and the Fronius smart meter will take over the data from this third-party inverter, take the PV surplus energy and send it to the Wattpilot. So with these external sources, you have also the possibility to install the Wattpilot solution with third-party inverters, with hydropower plants, with wind turbines, whatever brings in AC power in this system. Yeah, second one is then charging with multiple charging stations. Of course, this is possible with the dynamic load balancing. However, as I told you, the PV controlled mode is only available on one Wattpilot at the same time. So in this case, for example, when you're charging 2 electric vehicles, you have one Wattpilot PV controlled, PV optimized, and the second one, for example, is only being charged at 16 amps fixed. So this is a fixed charging current, and then you can charge multiple devices at the same time. However, with dynamic load balancing, of course, this charging current will be limited, will be controlled depending on your household connection and depending on the loads in the household. Yeah, I hope I could give you a little overview about our e-mobility solutions, about the Fronius Wattpilot today. I hope this information was useful for you. And of course, therefore, I want to invite you to our trainings. If you are interested in more e-mobility solutions, if you want to know more about the Fronius Wattpilot, or even about battery storage solutions, about backup power solutions, please feel free to visit one of our trainings, either live here in Wels. We have face-to-face trainings available, or if you are further away, we have also available online trainings for you that you can want to visit. So therefore, please check out our Fronius homepage, and as well as I want to guide you here to the www.fronius.com/wattpilot-guide. And there you can find all the video content related to Fronius Wattpilot. So whenever you want to know more into detail about the different features, about the different functionalities of the Wattpilot, please make sure to watch our YouTube channel here and see also the how-to videos on the Fronius Wattpilot. So whenever you have problems with the different functionalities of the Wattpilot, please make sure to watch our how-to videos on YouTube. So to sum that up, Fronius Wattpilot is the idle charging solution with and without PV. So no matter if you have an existing PV system or if you're planning on doing so, you can use the Fronius Wattpilot as your idle charging solution. And of course, we will make sure that we are updating the Wattpilot on a regular basis. So whenever there are new functionalities for the Wattpilot, all you need to do is to update it to a new firmware version, and then you will get the newest software updates over the air, and therefore you are future-proof to get a future-proof charging solution. Yeah, I hope this was informative for you. I want to say thank you for your today's participation, and in this case, stay healthy and keep charging. See you the next time here at Fronius. See you and goodbye.